Hi, my name is Carly, and we are going to be doing the interactive advanced concept presentation for today. And we are going to be discussing the transfer of heat between gas and liquid. For this experiment, we were asked to watch a video of a woman that was cooking in a plastic bag filled with water, and we're asked to explain how or why this is even possible. So we are going to answer that question today, and we are going to test. So my hypothesis would be that the plastic or a balloon that is filled with water will not catch on fire in comparison to a balloon or a plastic bag that is filled with air. So I have my balloon filled with air and my balloon filled with water, and I also have my plastic bag filled with water and my plastic bag filled with air. So we'll start off with the balloons, and then we'll kind of talk about why this is happening or why this is possible. So first off, gas is a poor conductor of heat, while water is a good conductor of heat. So like I said, with my hypothesis, I believe that the balloon that is filled with air will more likely pop than the balloon that is filled with water, and that is because the gas that is inside of this balloon, which is just oxygen gas or atmospheric air, is not as good of a conductor of heat as that of water is. So the water should absorb the heat of the flame that we have, and the balloon should not pop. And the same thing applies to the plastic bag. So I also have a flame, so we are outside today, and I also have a bucket of water in case if we have an emergency and something sets on fire, then we can submerge it into the bucket and put out the flame. So we are going to start off with the balloon, and I'm going to put it over the flame, and we will see what happens. Ooh. Okay, here we go. So a small hole, and it burst rather quickly. So like I said, it is because the gas that was inside of the balloon is a poor conductor of heat. So the balloon was able to reach the ignition temperature quicker. So now we are going to test it with the balloon filled with water. And you can see that it is not popping, and you can see some of the residue on the bottom of the balloon. This is actually just carbon that's left over from the flame, but it is warm, and the water is a good conductor of heat, so it was able to absorb the heat of the flame before the balloon could pop. So now we will do the plastic bag of air. This is the one that I'm worried might catch on fire. Okay, so it's immediately starting to melt. And there's a hole, and you can see, I don't know if you can see very well, right here is a little bit of that carbon that's left over. So it didn't pop necessarily, but the plastic in comparison to the balloon popped, and it's made of rubber, and this plastic just melted. But still, the gas that's inside of the plastic bag was a poor conductor of heat. So now we will do the plastic bag filled with water. And it is, again, not catching on fire or popping or melting, and that's because the water is a good conductor of heat, and it's a little bit warm, but nothing crazy. So this tells us that it is true. You can cook in a bag or in a water-filled bag. So I mean, I think that eventually it would probably catch on fire, but it just depends on the type of plastic that you use, how hot is the flame. But this does tell us that at some point the water that is a good conductor of heat would heat up and you could probably cook in it. So we were asked to come up with another phenomenon as to how this is possible or practical in life. So my example is a coolant in a car. So the coolant has a water pump, and like we said, water is a good conductor of heat. So when your car engine is heating up or is hot, the coolant is what helps cool down the engine or keep the engine from overheating. So because of the water, and there could be other contents in the coolant besides water, but liquid itself, the water liquid is the good conductor of heat that is able to absorb the heat from the engine and keep your engine from overheating. So this was my interactive advanced concept presentation and thank you for watching.